Hi everyone, we're going to talk a little bit about redox today. So bear with me with the gaps between the presentations. I'm going to do this all in one take, and as you can see I'm not particularly high tech. So 16.5 and redox, we need to first know what the oxidation state of something actually means. So let's say that I've got an atom, there's my simple representation of my atom. You can see it's got a number of electrons around it. So the oxidation states that we're going to define in this assignment are a kind of measure of how many electrons there are around the atom compared to the atom normally. So this atom normally likes to have 3 electrons around it, but it could lose an electron. You've met that at various points. This will now be an ion, of course. If it's lost an electron, it's got fewer electrons around it than normal. We'll come back to that in a moment. And of course, the alternative is it could gain an electron, in which case there will then be more electrons around the edge than before. So electrons, as you know, have a negative charge. So if we add more electrons in, we make the whole thing more negative. If we take electrons away, if we lose them, we make the whole thing more positive, okay? Because of that negative charge. So the oxidation state actually becomes more positive if I lose electrons. If I take them away, it increases. So let's just rewind a little bit. We started with our atom in its normal situation. That's got an oxidation state of 0. No change compared to the normal atom. Losing an electron, to make this one, our oxidation state increases. So we lose, increased. And down here, if I gain one, I've put more electrons around the outside, but that means I have put more negative charge around, so I'm going to become more negative. So the oxidation state is decreased in that second one. Right, while you're doing these, while you're working through this assignment, you're going to need to be able to assign an oxidation state to something. You're going to need to be able to tell me if something is 0 or if it is +1. In this case, we have actually got +1 because we've only lost 1 electron. So that's a simple way of doing it. There are a few rules you need to know about how to do this, and the idea of this video is I'm going to take you through a few of those rules. So the thing you're going to need is this sheet telling you all the rules and all the facts there are to know about oxidation numbers or oxidation states. Okay, different words for the same thing. We're going to break down a few of those now. We're not actually going to do number 2 because you've already got a nice example there. If something is a simple ion, like that +1 in the previous one, the oxidation state is the same as its charge, rule 2 there. We're not going to go over in that one in detail. We are, however, going to do some of the others. So there they are again. This is the sheet we're focusing on for the time being, the part of the sheet. Okay, we're going to look at S8, that's sulfur, sitting around bonded to 8 others, each sulfur bonded to 7 other sulfur atoms, a little set of 8 atoms. We look at H2S and SO4 2-. These are all sulfur containing species, and we want to know the oxidation state of the sulfur in each one. Okay, so S8. Well, for S8, I need to use rule 1, which is for an uncombined element, the oxidation state is 0. Now, you may think it's combined because I've just told you each sulfur is bonded to 7 other sulfurs, but because it's only the same atom over and over, the same element over and over again, there's no other elements present, that must be 0. So you can write at the top, 0. For now. Okay. So that's the F8. And now we're going to be using rules 3 and 4, a little more complicated for the next two. So rules 3 and 4, this time we're going to look at if the sulfur is bonded to something else, not just other sulfur atoms. So the first thing we need to be aware of is that we're going to have to account for the charge of the substance. Okay, well, I'll show you how to do that in a moment. And then we're going to have to look for some reference elements. Whenever you're trying to work out what the oxidation state of an element is, it's useful if you know the oxidation state of one of the other atoms it's bonded to. So here's hydrogen sulfide. And students find doing this sort of thing quite tricky sometimes. So they find the maths quite hard. What I'm going to try and convince you of now is that the maths is not difficult. In fact, the maths is so easy, we can do it with this simple number line. And if we were in a lesson together, I would be asking you to write out a number line in order to do this. So I recommend you do that. +6 down to -8 we'll need. Now, here's H2S, and we're actually going to start, well, let's start with rule 3, because rule 3 is the one that's written there. Rule 3, for substances containing more than one atom, the individual oxidation states of the atoms must equal the overall charge on the species. This charge, the charge on this, although it hasn't been written on, is 0. Okay, we're trying to get to 0 for this thing. How do we get to 0? Well, first of all, we have to look at what reference elements we've got. Have we got any oxygen, which has a state of -2? No, we don't. Have we got any hydrogen, which has an oxidation state of +1? Yes, we do. That's going to be relevant. And we haven't got any of these other ones. So, rule 3 told me that the place I was trying to get to, the overall combination of all of the oxidation states in this thing had to get me to 0. That is my target, because the charge on the species is 0. Rule 4 told me that I've got some hydrogens in there, and hydrogen is +1. So I can actually write that at the top. Each hydrogen atom has an oxidation state of +1. Okay? And there are 2 hydrogen atoms. So the hydrogens are going to take me up my number line. They're going to take me to +2. So I'm starting there. I'll do starting on the right. So because of the hydrogens, those 2 hydrogens, I've ended up at +2 to start with. So +1 times 2 + 2. See, simple maths. The sulfur, in order to get me back down to 0, I've got to go back down my number line. How far down? Well, 2. That is a change of -2. So the sulfur has an oxidation state of -2. Okay, so that's that one. Next one. We're again going to use rule 3 and rule 4 for this. It's another sulfur-containing compound. And one of the things I wanted to show you this is here we might see the sulfur having a different oxidation state to last time. Right, so this time we have a charge of 2-. Okay, so we need to reach this point here on our number line. That's the target. We're aiming to get to this charge here. Well, is oxygen one of our reference elements? Well, if you look back at your sheet, you'll see it is. Oxygen is -2. And again, there are 4 oxygen atoms involved here. So each oxygen atom is going to take us down by -2. So those oxygen atoms all together mean that we need to start this process at -8. -2 times 4 is -8. And last job, if we apply rule 3, we need to use sulfur to get ourselves back to -2. How far did we go? Oops. Well, it went +6. Easy, right?